In this lesson, my students are comparing the key characteristics of linear, exponential, and quadratic functions. And in this exit slip, I'm having them look at an exponential decay problem. It's modeling a real-world problem of if 300 milligrams of a dose of penicillin was given to a patient, that if 60% of the antibiotic remains in the body after each hour, how much penicillin remains in the body after 5 hours. So I want my students working more with problems that involve percent because they seem to struggle with it a little bit still, and they just need more practice with it. So, and also with writing the equations of exponential real-world problems. And so if you look at, I wanted them to find the common ratio. So if you had 180, divided by 300, you do get 0.60, and you get that common ratio. If we tested 108 divided by 180, the previous amount, you also get 0.60, and they can continue and show all of those where it's showing that that's the common ratio or the multiplier that's being multiplied on the output values. So that's your B value if you write the equation. We had learned two different ways to write the equation. One was just y equals the initial amount, which is 300, times the common ratio or that multiplier, which is 0.60, to the x power, or they could write the equation using the decay factor. So if you had 300 was still the initial amount, it's also the a value in this problem, this equation, and then you would have 1 minus, because it's a decay problem, 0.40 if you wanted 60% to remain. And so that would make to the x power, that would also be an equivalent equation in a different form. And so if we looked at, and if they tried to find how much penicillin was left after 5 hours, most of my students just continued and multiplied the last milligrams, 38.88 times 0.60, and that gave them the amount remaining after 5 hours, which was 23. After 5 hours, .328 milligrams remain in the body. And so if they went ahead and graphed that, that would have been between 0 and 30 based on the scale that we had. And they could have scaled it differently as long as they represented the input and the output values on their table. And they can see that it shouldn't cross the x-axis, that it is, that's going to be, your horizontal asymptote is at y equals 0.